Hello, everybody. My name is Peygam Ghaffari. I'm senior researcher at Akvaplan-niva, and we are officially starting the second workshop of CRIPTIC project. I would like to give some information about the CRIPTIC project because I see new faces here, and I also see a good combination of people from different levels, from professors at university to fresh students. Which is good for our workshop, and we have a wide spectrum of the audience in this workshop. CRIPTIC project is a project about plastic in the Caspian Sea, financed by Norwegian Retailer Fund. Norwegian Retailer Fund is the largest fund in Norway for combating, cleaning, and researching on plastic, mostly microplastic. And there is one discipline in the Norwegian Retailer Fund for international projects. CRIPTIC is funded by this part of the Norwegian Retailer Fund. The main approach of the CRIPTIC project is study of the plastic introduced to the Caspian Sea from the Kora River. As you know, Kora River is a transboundary river which pass through several countries and end up to the Caspian Sea. So we consider Kora River as a pilot project to understand the plastic, microplastic introduced to Caspian Sea and how we can identify microplastic in the Caspian Sea introduced by Kora River and how we can combat with that. Also, we have a strong public awareness section in this project. As most of you know, but some new faces don't know, we conducted a series of workshops. This is the second workshop. First workshop was devoted to the protocol development and field study in the Kora River bank and Caspian Sea. Now we are on second workshop, and the main approach of the second workshop is remote sensing and machine learning in identifying plastic in the Caspian Sea. There will be another workshop we'll announce later, which we will address more thoroughly public awareness and modeling of plastic in the Caspian Sea. After my introduction, Elnur from Azerbaijani side will introduce the Azerbaijani partners and will have a couple of words about the Azerbaijani take of the project. Then we will have Niels for 15 minutes, and he will have a lecture on what is OBIA, machine learning, deep learning, and AI. Then the workshop will be followed by a presentation by Alexei about the citizen science and public awareness. We will have 15 minutes technical break afterward. Then we will have a session by Bert regarding the follow-up the work has been done in 2021 and future work. Again, we will get back to machine learning and remote sensing. Niels will have a lecture on using OBIA and machine classification for debris detection in CRIPTIC. Then we will have open discussion for 15 minutes, which all participants can put forward their thoughts, and afterward we will have concluding remarks by Elnur on behalf of Azerbaijani partners, and I will conclude for 5 minutes this is the whole sketch of the workshop. And I think we can start by giving floor to Elnor. Please, Elnor.
Hi everyone, good morning. Very happy to see you, most of you again, and some of you maybe even me first time in my life, but hope that you all will enjoy and find this workshop really useful, really helpful in your future life and actually within our incoming years work perspectives in the region. My name is Elnur Safarov. I am a senior scientific researcher in the Academy of Science Institute of Geography, Caspian Sea Problems Department. In this project, I represent several organizations in the same time, Institute of Geography as one of the partners of the CRIPTIC project, as the leading Azerbaijani organization, Society of Azerbaijan Geographical Society, as a CRIPTIC Azerbaijan project manager, and also one of the active partners of the CRIPTIC in Azerbaijan, coordinator of the CaspisNet. Well, actually, information about what we are doing, what this project is about, thanks to Pegam, he already give to us, and I'd like to introduce or just to give brief information about our other partners. Mostly, this is the NGOs like Azerbaijan Geographical Society, also Azerbaijani water experts unions, and then Azersu. It was at the beginning of the work. They also was a part of, and now they are represented on the level of the Sukanal Institute. Some researchers from that organization. And by the way, we have very actively attending and supporting CRIPTIC project private sector, starting from British Petroleum. Actually, I see the representative of the, participant from the BP. Happy to see you again. Then our active partner is the Akvaplan company, which support us with the drone mappings. Thanks to them, actually. Then Esri company. After that, Caspian Locus, Caspian Geomatics, Asgreen, some other companies which in different level support our project in order to make it as good as possible. And we will see in our next workshops, incoming workshops, their impacts in more detail. In general auditory, what participate today is the mostly riparian countries, European Union countries. We have the members starting from Italy to Italy, Switzerland, Turkey, Iran, Russia, Kazakhstan. Actually, Emil now representing Kazakhstan, being Azerbaijani. And we have several researchers from Academy of Science. Rustam Malim, by the way, he is one of the leading specialists. He represents Academy of Science, also Hazar University in some way, and many others. And students. I hope you all enjoy the workshop. I hope it will be really helpful for you all. Don't hesitate asking questions. Maybe you have a lot of questions in your mind, just note it, and at the end you can ask. Because of depending your questions, we will evaluate the level of the contingent, the auditory, and our next workshops will be created according to your level, professional level. I also congratulate Naitavan Jafarova. She is one of our active members in the project and actually the representative of the Azerbaijan Geographical Society as well. And the daughter of our famous and very lovely Professor Ramiz Mamadov, who is not with us today, unfortunately. Bye-bye.
Thank you very much, Elnur, and thank you for introducing Azerbaijani partner in detail. And I'm happy to see again, different faces and new faces from different levels, as you mentioned, from professors at university to fresh students. And this is what exactly we need. We need an auditorium like this to be able to address all problems. As you mentioned, questions are quite important. The chat box is open and people can write the question chat box. The same time they can keep question for the end of each lecture, because the 10 minutes of each lecture and the last 10 minutes will be devoted to questions and answers. So they can talk during that 10 minutes addressing their question, or they can type their question on the chat box. We will see those questions and we will put that questions toward the lectures. Also, we will have open discussion, which the participant will have opportunity to put forward their questions. Also, I need to introduce a Norwegian partner. From Norwegian side, I introduce Norwegian Retailers Fund, which is the founder of the project. But Akvaplan-niva, which is Norwegian science-based company, is leading the project. Beside Akvaplan-niva, Norwegian Water Research Institute NIVA is one of the partners of this project. And also another Norwegian company, SALT, is another partner of this project. And also Terranor is the other Norwegian partner, which is dealing with remote sensing and machine learning. I think it is time to give floor to Niels. Are you there, Niels? We are a little bit ahead of time, but I think it's good to be ahead of time rather than be late. Okay.
Okay, good morning, everybody. I just need to get things up and running, and I assume I need to share my screen.
Yes, please.
I would suggest, if you have problems with communication or seeing things, turn off your camera, because then you will have more speed for listening. Of course. Here we go. Right, you can see it, everyone?
Yes.
Excellent.
We see your presentation. Please, floor is yours.
Thank you very much. Okay, when I hear this presentation of all these professors and scientists, wasn't sure if I'm going to be a little nervous, because I'm going to present advanced stuff for you. But then I hear there's a lot of students here as well. So when I wrote this little session here, I wasn't sure if what level I would find myself on, but I'm a very practical person. I do a lot of training in GIS and remote sensing, and many of my students are PhD candidates, or they have a PhD. So I think what I found that most people need to learn a little bit more about the practical side of remote sensing and what it actually is. And this is what CRIPTIC is all about. I'm going to tell you a little bit about how we worked with this project for CRIPTIC, what we did. There was mentioned AI and machine learning and OBIA. Let's take OBIA first. It means object-based image analysis. And that's a very important part of machine learning, because we need we're looking for objects on the ground. We're not looking for pixels. There are many software that deals with pixels, which are brilliant software. But the software we work with, called eCognition, works with OBIA. And we're going to talk about what this is. But before we start, when you do a project like this with remote sensing, then you have a question: why do we want to analyze this data? What are we doing? Why are we doing it? Very often people are not clever enough to ask this question. So when they have a solution and solve the problem, they're not sure if they actually solved the problem that they should have defined. So it's very important that you analyze this question, and because you need to know what is good enough. Is it good enough, or should you do something more? Second question is, what are you looking for? Are you looking for timber? Are you looking for plastic? Are you looking for fishnet? Or what are you looking for? Old car wheels is also mentioned here. So it's important to know what you're looking for, and if we can achieve that with this thing. And lastly, how will you do this? And this how is what we're going to talk about today. First, a little bit about data normally used for remote sensing. I think it is a little bit beyond what we did in CRIPTIC, but it's important to know, realize that the number of sensors and the number of data input is increasing every day. Last week, I worked with a French company, government agency, that worked with new hyperspectral imagery from the seabed. This is completely new, and I haven't seen that it's been done before. So things are happening while we're sitting here and continuously improving. LiDAR is a typical thing where you measure light that's sent out from the plane and hit the ground, and you measure the return pulse. In the beginning, it was very good to have 1 pulse per square meter. Now you can have up to 100 measurements per square meter, and that means you can have a good estimation also of the ground and the top of the trees. So this is one way. The most common things that people are forgetting is the air photo. In the Scandinavian countries, we do survey the whole of the country on a regular basis. In Sweden, they try to survey with air photo all cities once a year, and the more rural parts maybe every 6 years. It means that you normally have very good photos for the whole country that are up to date. This photo you just see classified for these industries, but air photo is a brilliant source of information, and very often is quite new. In sister project to CRIPTIC, this is from a Molinor project from Akvaplan-niva up in northern Norway, Finnmark, where we used satellite image from European Space Imaging. It's a WorldView 3 image you're looking at here, and I'm gonna mention a little bit about that. Then you of course have radar. That's not very much handy for finding plastic, but still I thought I would mention that. It's extremely good for measuring heights and changes in heights. So if you're looking for things that are going down in the ground, radar is a brilliant tool. Then of course, what we used on CRIPTIC is drone. And to the right, you have maybe the finest and the best drone in the world. And our last partner, Frank Rachel, took this photo, and he loved taking photos of eagles. And I was with him several times, and he has hundreds of these photos from our trips. But I think what you're going to talk about today is how we work with drones and analyze them. First, a little bit about quality. When you work with analysis, over the years, and I've been working with remote sensing since 1995. In the beginning, I was a rookie. I didn't understand much about it. But after some years, I understood more and more. One of the most important things I found was to work with the right resolution. Many people think that if you just get the highest possible resolution, you will get the best result. That often that is true, but not always. When you survey forestry, especially large trees, you do not want a resolution less than 50 centimeters. Here in CRIPTIC, we went down, we started with 8 millimeter. That's less than 1 centimeters, which is very accurate. That's the image to the right. And the image to the left, it was the first image we received is, I think, probably 3 or 4 centimeters. So the resolution should be fine enough to find the object we're looking for, but coarse enough not to do long processing time. Later today, we're going to show you the processing and how we process the data. We're going through a real world example, and then you're going to see how it works. And some of these processing for this image, when you have worked with 8 millimeter, took about 1 hour. That's just one of the processes. So in total, it would be maybe 1.5 hour processing time. Sorry. This is not a big deal because you can just turn on the computer and the software and ask it to run, and you can come back after 2 hours and the result will be there. But still, when you're developing and look at stuff, things takes time, and you don't want things to take too long time, especially if you have many images. So when you work with the pixel size, normally when you have an image, you can reduce the pixel size yourself when you enter the data into the software. And you have to look at how large areas to map. If you're looking for half of our Azerbaijan, you wouldn't work with 1 millimeter. You would work with something maybe 100 meter or 50 meters. So you need to look at what do I want to find. So that's where you decide your pixel size. The other thing I found, and this is I work with several large companies, really advanced scientists in oil companies and other places. They have no clue about what imagery is. So when you talk about 12-bit, 8-bit, they have no clue. They just look at, okay, we're going to need some images for this project, and we have surveyed it, and we got thousands and thousands of images. When I look at it, and okay, so you got JPEG data. Yes, because that takes less space on the computer. Yeah, but then you have reduced the information we have. Normally, we want to have 16-bit data, but if you look here, you see 12-bit. Normally, the sensor we work with will have 11-bit, 12-bit, 13-bit, 14-bit. 14-bit is normal for aerial cameras today, but the data you receive is 16-bit because that's what the computer can read. But it doesn't help because you are stuck to that. But still, 12-bit compared to JPEG with 8-bit means that each channel has got 16 times more information per channel, or in total 4,096 times for each channels. It means that if you're looking for things that has a small variation on the ground, or what you see with a 12-bit data or 16-bit data, you can find a lot more information than you do with only 8-bit. So if possible, ask for raw data, and drones can deliver 16-bit data. Some of the drones are really brilliant. So do not automatically go for the JPEG. Try to get a hold of the raw data. In reality, the difference is smaller because data do not cover all these colors. So they kind of cluster in the middle, but still, it's a huge difference between 16-bit and 8-bit data. Okay, come on. So here we show the difference in easier to compare the difference in information when you can look at visually. And this shows the difference between 8-bit and 16-bit data for when you have 12-bit sensor. So it's a physical way of understanding that. When you get the data in, sometimes you need to manipulate the data. There's a lot of manipulation routines in most software. What we call filtering techniques. One filtering techniques is what we call bathymetric position index. That's for the seabed. On ground or on land, it will be topographic position index. What it does, it actually tells you if the area is flat or if it's curved. So you see here, this area is actually flat, but it's going down. But here you have a bottom and you have a top. And routines like this tells us a lot about the terrain. You can also look at rugosity and things changes over the ground. So look at the steps that we're dealing with in the processing. Sorry. The first thing when we work with in an OBIA is to do segmentation. And Recognition was the first software sorry, in the market to do a real good segmentation. Segmentation, what it does is groups equal pixels together in objects. So from the pixels, you create polygons. And here you see the blue plastic has become more or less a rectangular object, while the seaweed becomes more irregular. These things we can use for analysis. Because when we have a polygon like this one, we have features for each polygon. First of all, we have the area. Let's say we are looking for plastic bottles or something like that. They will have a minimum area. So that's one thing you can look for. Then you have the shape. Obviously, this blue plastic has a different shape than the seaweed. And the sand also has different shape. Texture. If you look at the texture on the sand and here in the seaweed, they will have a different texture. And perimeter itself is a useful thing. Elliptic fit. It's a kind of shape. That too is how round an object is. If you're looking for round objects, elliptic fit is something good there. And of course, you have the values of each layer. We got 3 layers here, RGB, and you look at the values of each layer. And standard deviation within, and for all the things we talk about within each polygon. So we look about standard deviation for each channel within this polygon. And there's some thousands more. So once when you get a polygon, there's so much more you can do than if you only have a pixel. The software we're using, was developed by Dr. Geir Binnig back in the 1990s. He's got a Nobel Prize in physics in 1986. Went on, and most important part was that in 2010, Trimble acquired the Earth version of Recognition and has developed it later. We were quite wondering what will happen with when Trimble took over Recognition, but it has developed Recognition a lot, especially for the things we need, not least about LiDAR. So it has been a great thing that Trimble took it over. So what is it? You think about, you have the ground, the real world, you take an image, a photo, LiDAR data, like elevation, so you get rasters. Each pixel represents a measurement on the ground. So then you combine it with your own land cover map. Because it's sometimes important to know that you want to analyze only part of the municipality or property and not everything. So there are many levels of information on the stack here that you can use. So what is actually object-based image analysis? And why do we see what we see? The human perception. When we see things, we analyze the groups of pixels. We incorporate the tech context. That means what is around what we see. And it works on multiple scales. I think some of you will recognize what this is right away, but some of you don't. It could be anything, actually. So if we bring in some more context, you start to see what it is. And most of you can now see that these are people standing on a roof. And I'm not sure where it is, but people going to have a viewpoint looking out of the city. So this is how eCognition works. It works on pixel, create polygons, and you look at things on the neighbors and what context it is in. So we have input to eCognition will be raster. We have vector data and we have point cloud. And by the way, we are reseller for eCognition, just to mention that. That's also why I got access to a lot of good files from Trimbles. So all these data that we work with, eCognition will fuse as raster, vector, and point cloud data stacks. And they will create polygons from these data. So you start with the pixels on the bottom. You create small polygons, larger polygons, and big polygons. So these can use pixels, objects, and object networks in analyzing the images. So we use context rule. If this is an suburban, we can look at these as properties and their gardens. And we can look at the changed building. So we put in existing buildings and we map new buildings, and we got changed buildings. So this is how it works. Then we're trying to merge together things that we think belong to each other. And we can combine 2D, 3D, and time series for these analysis. So there's a huge range of possibilities here. And when you're finished, we export the data. We can export in raster, vector, point cloud, and reports. Normally, we would like to export vector data into GIS, but sometimes we're just looking for the report. So, I think we're not going to come back to this. Let's say I'm kept now for. I have to look at the watch because initially I looked at the time and I saw when I should be finished. So now I have to calculate the watching.
Niels, sorry
Yeah.
for interruption. I have calculated time and I will inform you when you need to finish.
Yeah,
Still,
please
you have some more minutes to go, and when your session is finished, the lecture part and the questions start, I will inform you.
That's nice.
Yep.
Because
I have another almost 20 minutes to go.
Yeah. Let's move on. Segmentation can be done many different ways. And some of these segmentation routines are very simple, but could be very handy and very useful. This first type of segmentation routine we look at is what we call chessboard segmentation. What it does is actually create square rectangles on an image. It's fast, no spectral awareness, and typical application tile trees translate vector boundaries into object outlines. Very often you want to know the number of things that are inside other polygons, where this is very handy. So there's a huge amount of use for this segmentation routine. Then you have something called quadtree. Then the reason for quadtree is that it's very fast. It creates what it does. It divides the image into 4. Then it looks at each rectangle, and if you look here, you can see the area here is quite equal, so as it becomes large. Where you have variation, they will divide the polygon into 4 and into 4 and into 4 until there's no change anymore. So this is how it works, and this method is extremely fast. Doesn't look too good, but I tell you, it can be very handy for doing things fast. Then we have the real thing, what you call multi-resolution segmentation. What it does, it creates smooth representation of spectrally distinctive regions. The most important part, you have variable scale, shape, and compactness parameters, and layer weights. Some layers can bring more information into the segmentation. You can apply it to a pixel level, or you can do it on an existing image object. Very often you will divide your image into, let's say, water and not water, and then you will do multi-resolution on the not water. It gives the best results, but it's computationally intensive. Typical applications, accurate delineation of distinct features, creating multi-scale object hierarchy. So this is the one you would want to use, and I'm going to show you later today how we used it in this CRIPTIC project. Then we got some variation of this where you can grow, and there's several more variation of these multi-resolution. And then you have spectral driven segmentation where you divide based on the spectral value of one layer. And of course, you have image object fusion where you can combine objects that are similar. Then you have merge region. So many of these functions you will use in combination, or you don't normally use only one segmentation routine and classify. You combine a lot of this stuff, and you get a huge rule set that travels through your data set. A very good new function they added a couple of years ago was something called pixel-based object resizing, because when you get an object, you normally not often get the right edges. So you can have what we call pixel-based object resizing, where the algorithm creates larger polygons based on some criteria. So when we do the classification, there's several types of classification, and this was actually the subject for today. One thing is what we actually ended up using in CRIPTIC was assign class, where we used threshold values to define the object. I'm going to show you later why we did that. We got something called fuzzy logic, something that where it actually goes for probability for being one or the other thing, and it checks several classes to see what class the object should belong to. Then you come to what is called machine learning. We have sample-based classification. There are 5 classification routines in e-cognition. We got nearest neighbor, Bayes, support vector machine, classification and regression tree, and a decision tree. So there's anyways, if you want to know about them, you go on Wikipedia. You realize that most software companies that work in this area, they will use scientific reports from universities to actually implement in their software. So that means that all the software is scientifically based, so you can actually estimate how good they can be. What I can show you later is how different these classification routines actually can end up. And lastly, the big thing, deep learning. Everyone wants to use deep learning until they realize that they have only 40 samples and they maybe wanted to have 4,000. Deep learning is a brilliant solution because it uses what you call convolutional neural network. And by using thousands and thousands of samples, you can get a very accurate classification. Cognition has implemented TensorFlow from Google and wrapped it into their rule sets. And the good thing with Cognition is that they can make thousands of samples automatically. But sometimes this works well, but I tell you, this is not it is not artificial intelligence, that's for sure. It's a routine. One thing you need when you work with polygons and you want to classify them, this is segmented based on the bathymetry. Just use as an example. The computer sees the images just like numbers. So each polygon will have a series of numbers that are reasonable, equal. And so from this bathymetry, we create slope, backscatter, standard deviation, and several more. And all these can be used in the classification. So when we do the classification, we will have, for each polygon, we have information. And because we can create more rasters for each, from the data we have depth, we have backscatter, slope, PPI at 25 pixels, PPI 5 pixels, rugosity 5 pixels, aspect, etc., etc. And of course, size, shape, and the neighbors. All these things can be used for automated classification. So this image was done for Norwegian Geological Survey based on routine we just saw. Is taken out in the North Sea and classified an image in 10 minutes. But it may take you 3 weeks to create the rule set, but then it will take you 10 minutes to run it. So the work is not classifying, the work is creating the rule set. When we classify objects, we get data, and this is what I think is important to look at quality. Some years ago, I got some data from oil company. And when you take underwater images, some of these images are dark in one side because of the light does not penetrate water very well. So we could not analyze it. So at the end, my company, we decided we had to do something with it. So we created the software to enhance the data. So if you look up here, it's dark, but here you can see what it is. Now this is not needed for the CRIPTIC project where we are on land. But some of you, especially the young students, in the future, you will probably work down here because the oceans cover 70% of the Mother Earth. And that's where all the minerals are hidden that we need for building our electric cars. I read an article about this yesterday that the next area that we will ruin will be the seabed. So then you need some good data to that. But before you have good data, there's no way you can classify this image. So this is how it was classified when you have that image. These type of images is probably very well designed for deep learning because you have a very good texture to classify on. So this is by having several of these, you can create thousands and thousands of samples just from one image. The other thing, when you classify, that was the first project we worked with the oil company. They're very careful with the environment, so they wanted to look at the fauna on the seabed. So doing so, we could not use machine learning because we had very few samples, and the object, the fauna we looked on the seabed, they were all different. The only thing that was common with all the things, because we had a black and white image, was a brightness. You see on the bottom here, they're all white and bright. So we can tell, okay, everything that's brighter than the things around, that's fauna. Then we realize that some of these fauna has a black spot in the middle, and I think we call that anemone. Then we also found out, you see here's a gas leak. There's a lot of gas and oil leaking out from the seabed constantly from the nature. We can actually detect this gas leak by looking at white spots, and they're all close to each other. So we say, okay, there's a lot of white spots in here, but these white spots are the only one that are clustered in a certain way. That we could do in eCognition by finding objects were close to each other, and then we said, okay, then it's gas. Well, these are not gas because they're not clustered in the same way. So there's nothing to do with machine learning, but when you process this automatically, we could process 10,000 images without doing any manual work. We just sent them through this software. Coral was interesting because the coral has the different shape and everything else. So we could actually differentiate coral from other fauna on the seabed. Some of the things I mentioned for you, these BPI stuff, and we use that to find coral on the seabed. This is a sonar image from some place in the world taken by Dove Subsea, and they wanted to find coral. Coral is something oil companies and others are very careful about. They don't want to ruin it, so they want to know where it is. So we found that, and we looked for BPI. Turns out, like, coral wants to grow on stones and things that sticks up. So if you have something sticks up, like you see these points here, and if they're small tops on top of the larger tops, then they assume that was coral. So in this way, we could actually classify a large area and find all the coral automatically. Sorry. Just by using the BPI, we can actually classify, and we used machine learning where we used BPI as an input, and BPI at different sizes. This is another one from Pacific. We were looking for pockmarks in the Pacific. Pockmarks are ditches in where it come from, I'm not sure, but the Northeast very often from the ice. I think it says here. So by using BPI, we could find these things. And since we have an obia, we could create objects and find if some of them were long, then they became green. If they're small and round, they became blue. And we could also go for the depth of them and classify based on depth. So you have long pockmarks that are deep and long pockmarks that are shallow. So we create our own information and do machine learning based on that. Then we did some analysis for IMR, Institute for Marine Research, where we looked for debris on the seabed. Sorry that I'm bringing too much from the seabed, where we're going to look at CRIPTIC data later, but we use the same technology when we do classification here. And here we found white plastic on the seabed, and we tried to exclude what's other white in here, which could be gas in the water or other things that white. It was quite complex. Then when you have an object, you can see something is round, other stuff is not round. So we could classify that as a debris, green plastic. You also have the color, but you also have the roundness because we have an object. This is a project we did before CRIPTIC called Malinur. This is the most important part we're looking for on the seabed is the fishnet. We used both satellite image and drones for this one. And you here is a classified image where we found white plastic and fishnet. This is drone image. And here's the same area with the satellite image. We found that we can detect a large object on satellite image if they're larger than 20 centimeters and have a distinct color. This is from them. We also found that the beaches we worked on up in Northern Norway were quite different from CRIPTIC. Sometimes easier to detect and sometimes more difficult. Of course, there's some glider images from Akvaplan-niva where we took images underwater looking at plastic floating in the water. This is actually done with deep learning. You see it, fine things. Okay.
Okay. Thank you, Nils. You are just on time. No, I was just about to tell you that you are entering to 10 minutes of question part, and I see. Thank you for listening. Okay, we are open for questions.
So, can I ask a question?
Please come on.
Oh, thank you so much, Professor Niels. That was really great, and thanks a lot. Appreciate it a lot. Like like from the beginning, you talked a lot about the actually, the radiometric and actual spatial resolution aspects, right? And I'm more than confident that the object-based like image analysis and multi-resolution segmentation that will actually segment the plastic on the ground. It's without any without any concerns about it. So segmentation will actually function pretty well. But the only issue, right? I'm more than sure also that your original drone data comes out of the necessary additional bands or channels, which are critical to separate and understand the spectral separation between, let's say, two types of plastic bottles, for instance, as an example. So the issue, like I'm absolutely agree that you are giving a lot of pressure to radiometric resolution here, that using the 16 beat stuff, it's going to work pretty well. But the issue, and using some other characteristics like texture, shapes, and all the stuff, right? And other like existing spatial stuff, spectral stuff, right? So as I said, how you are supposed to look at from the spectral separation aspects, right? Because your segmentation properties, your created segments will not give the opportunity to separate, to distinguish two types of the bottles of different types of the plastic. Yeah. All right, and that's it. So basically, segmentation will work, but the separation will have some challenges, I believe, about it. Thank you so much, Professor Niels.
Yeah, if I just want to comment on that, I think that was a great comment, because I think what we learn that most of the things we're looking for will be covered by dust. So the colors are not the original colors that you found in the shop when the bottles were bought. So yeah, and on the satellite image, which was 30 centimeters, we didn't use segmentation at all. We just worked with the pixels because each object were only so small that we looked at the colors of each pixel. So yes, you're quite right, and I thank you for pointing that out. I agree very much.
Thanks, sir.
Any other question?
Come on, students, this is the time where you can ask a question and no one can see you.
That's exactly what I was about to say. There is no stupid question. There is no bad question. Question altogether are good. So don't hesitate to ask your question without. Yannicka, please.
Yeah, I arrived a little bit late due to a dentist appointment, so I didn't get all your talk, but one thing that I've been thinking about is when we are doing these identifications using drones or satellites, that covers quite a large area, and it could either be used to figure out, okay, how much is there in total, and see if that increases or decreases, or it could be also used to identify items of high concern, like the fishing nets, so that when you're going to do do cleanups, you might want to go to areas that are either high in pollution or that have a lot of items of high concern. And I'm wondering whether you have some ideas about these items. Are there any items of high concern that we should be looking for in this project, and that could be picked up by satellite or drone images?
Thank you for that brilliant question. That was really a good question. Remember one of my first slides, I say, why are we doing this? And fishnet is one of these big whys, because we want to pick out the fishnet first. And I will show you later today how we detect fishnet and the other things. But fishnet was a specific thing we were looking for. And I'm very happy to say that we do find that very well. But your question is brilliant, really good.
Just a small question from my side.
Please, Elnor.
Maybe this is a simple question, but my question is that the drone images which were used in the field, are they good enough? I mean, mostly the question is that how accurate are they? How minimal size, which minimal size of the plastics they are capable in our work to detect? And the second part, I remember that when we started the work, we were planning that using for the big objects the satellite images, and for smaller objects mostly the drone. Is the resolution of the drone image what we have covers in detection of the fish nets, or we still need satellite resolution? I mean satellite images. Sorry if my question a bit mixed.
Yeah, I think that's a good thing. We were discussing, we were not part of the flying for CRIPTIC, but the data we got was brilliant. So I guess you did the right work down there. What we did in Northern Norway was we were flying in 25 meters, 50 meters, and 100 meters for the drones. And we looked at the different results. At 25 meters, we came out to be they gave us too much data. First of all, very high resolution and very many images, and you had to fly a lot. 100 meter was not good enough quality. Maybe with a better camera, we can achieve it a better quality. But with the data camera we had, we ended up using 50 meters. Which gave us just the right size. With the 15 meters fly height, we could get objects, well, the resolution was 1 millimeter. And in this CRIPTIC project, to be able to run it normally, I changed the resolution to 1.7 centimeters. So, yeah. So I think drone images, you find everything you can see by walking on the beach. Satellite images can find all larger objects like fish nets with a certain size and plastic that stands out. So again, it is what are you looking for, and what tools will you use, and how easy is it to come to a place and run the drone? In your area, it's probably easier, but in Northern Norway, it could be a long distance to the beach, and there are no roads up there. So there's a lot of practical things you have to consider when you decide your tools.
Thank you so much.
I assume there is no more question at this moment, and Of course. Oh, Alexei, please.
Sorry, there is
very short question, Alexei.
Really?
Yeah, because we have 3 minutes to
we are
finish
so
this
much
session.
ahead of schedule. Actually, I wanted Niels to improvise a little bit and go to this fantastic world behind him. Because, yeah, as I understand,
Well, it's a picture from my last holiday.
yeah,
Okay.
it is your future holiday in Azerbaijan also, I believe. But as I understand, you are mostly working especially when it comes to satellites. I will then end up only with one question. Mostly working with defining the plastic by colors.
Yes.
If you go a little bit into the future, what are the possibilities to go better than humans with identifying plastic using remote sensing and this, let's call it digital technologies? Because now we are learning machines, and I'm waiting for the time when we can relax and the machines will be doing our job and better than us.
Well, I think the result we
Niels,
have
just 2 minutes, not more than 2 minutes.
Okay,
we have 1 minute.
We are already there. When we see the things we found on the beach, we already see an object that we cannot see by looking at the images with our eyes. So, and the numbers, let's say we found a huge amount of fish nets that we would not have found if we only used manual eyes. And walking on that beach, trying to find them, that's also more difficult. So I think we're already there.
Okay, thank you, Niels, for very informative lecture. You start from sensor and different techniques, and you introduce different possibilities. You start from air, photo, satellite imagery, radar, drone, and then you put some technicalities in that by saying that it is important to get right resolution rather than high resolution or low resolution. Also, you put in some more technicalities like a quad 3, which was very interesting for me because it reminded me of fractals. When I was young, I was working on fractals, but fractals are not they are not squares. But what you showed me was exactly like as fractals. So, and you mentioned combination of several methods we use in this sort of projects, and then we dive to the ocean, and you showed us some underwater, the application of remote sensing and image processing underwater, and it was very interesting for me to see how you detect gas leak and other things. So, step by step in this journey, you actually prepared us for the next presentation of you, because you gave us some sort of general background about what we are talking about right now. And I didn't understand all what you said, but part of that. And that's very, very good, because it means that it was designed for a large audience. So most probably there are some people, they understood 100%. I understood like a 30%, and some people understood 50%. That was perfect. Thank you very much. And by this, we give floor to Alexei Bombulyak, Senior Researcher and Advisor in Akvaplan-niva. He is going to give us a lecture on a united platform for science and citizen. Alexei, floor is yours.
Yes, I hope you see my screen.
Yeah, you did it.
Yeah,
just a presentation mode. Thank you.
Actually, I can give it for 5 minutes and then let Niels answer my question for another half an hour. Actually, this work package is work package number 3 on citizen science and community engagement. But in reality, that is all the CRIPTIC is work package 3. That is the main philosophy of the project and the process. And this year is the final year of the project, but I will come to that. I will not say the last one. So actually I can start and end with this slide, because the title, it tells everything what should be inside. And we can have a huge discussion just around this first slide. Whether and in which extent right now CRIPTIC is a united platform for both science and citizens, and who helps whom, and whether these terms can be divided, whether we can have scientists as elite who educate and citizens those who receive education, or it goes the other way, or it goes both ways. So it is rather a question than the statement. But briefly, why Akvaplan-niva and what we else did? Niels already mentioned Malinor. That is a bilateral research project. And here there are 3 projects where that Akvaplan-niva leads. And we, as you can see in the top, have kind of similar logos for those 3 projects. And in all these 3 projects, citizen science and public awareness are important elements. And therefore, in order to come to CRIPTIC with the proposals on what and how to do, we had an experience of working cross-border with another projects. So I stop on the slides and not reading, so you can choose, so you can do both, listen to me and read what is on the slide. So a little bit about Art2Mal. That is the project focused on the Arctic. So as Niels went under the sea, we go high in the Arctic from the Caspian to also to show the broad context of, we can say the problem or the issue in general. But this idea came from almost nothing, from a discussion between 2 French people who met in Tromsø. And then they came up to the proposal, why not go together with cruise operators exploring the Arctic and tell a little bit more to those tourists that pay actually quite significant amount of money to see Arctic islands, to tell how responsible they are also for visiting the island, these islands, and visiting the high Arctic, not only being there, but also being in their homelands. Because those tourists that are coming to Svalbard, Spitsbergen, in both ways, and Franz Josef Land, for example, or even go to the North Pole, actually they bring up themselves to these high Arctics, but plastic goes without them from their homelands. So that was the main idea, to tell a little bit more on what and how people do and how they can help. And then, of course, it was one idea is to educate them, and also another idea is to let them do something good, as all of them think. To go out to the beaches and identify plastic and clean up and so feel themselves a part of this cleaning the Arctic after the global pollution which is accumulated there. And actually the main idea was not so much to involve them, to have their hands in reality to clean these remote areas, because that is also the goal, but not the goal of that project, but more to let them be aware of the scale of the problem. And then we were also using apps. We tried them on the high Arctics, and that is more difficult than in the Caspian region, due to, Niels knows that satellites have very good coverage closer to equator and very bad coverage temporary in the high latitudes. But anyway, they were using apps, and it was interesting that many of them, they started to follow the problem and look at the images when they came back. So that was actually our main goal, to spread the idea about the project, or through the project about the problem as such. So it was more like an infection of a good knowledge to be distributed. Unfortunately, another virus stopped our project in 2020. So we had the expedition with tourists only in 2019, but the idea was good, and we hope that it will be continued. So this was one element, and another element, and both Malino and Artomar, is in outreach. Use all possible or any possible ways to spread information about our activities, and going both for speaking about the problem or the challenge, and about cooperation between different institutes, between countries, in different sectors, in order to look for the ways to solve the problem. Because in these projects, actually, solving the problem as such may not be the main goal, but the process of solving the problem could be even more important than the concrete result itself. So that is what is quite unique with these emerging pollution issues and projects, that actually we are not even in the middle with this challenge. We are already in the start, and we should be prepared for the future. So with these experiences, we came to CRIPTIC, and you know very well the partners. They are representing Norwegian and Azerbaijan institutes, but we had a meeting, several meetings recently, and one of them was with Begum and Bert. And it was interesting that three guys from Norwegian institutes met, and they were by nationalities from Netherlands, Iran, and Russia. So we can count how many nationalities we have here, and that is also one of good examples of these bilateral, which are actually multilateral projects. Because that is the project with partners at from Azerbaijan side, there are few listed, and we have much more, and the numbers are growing, because we also look at all NGOs, volunteers, members of the seminars that attended the first seminar and the second seminar, participants of the field trips, of courses. All of them are contributing to the project, and all those who contribute, they are called partners. So the list here is limited by the screen, by unlimited by reality. And then we have, of course, as I told, this work package number 3 on citizen science and community engagement. And that is a very nice poster we have, demonstrating the arrows actually going both ways. And that is extremely important for having that in mind of everyone, especially of those people who are giving lectures here and expecting questions to come. I would actually challenge you and myself to ask questions yourself to auditorium, because it looks like we do not know everything, and we are, as Norwegian institutes, we are working in a territory that is not our territory. We do not live there, and for me, for example, I have more questions than answers on what is the best way to reach our ideas or to reach kind of results, concrete results, but more kind of philosophic results in these projects. So that is the both ways, and actually not even 3D, it is multi-dimensional roads that goes everywhere for different subjects of science, to different groups of people, different countries, different ideas of lives and so on, and paradigms even. And then in this community engagement, we have 3 tasks. Education information materials, that is ongoing and will be ongoing. Workshops, meetings, and training courses, and field trips, field expeditions. That is probably one of the most interesting and most important element of the project. And that is not me to tell about that. I hope that Elnur or his colleagues can comment after this presentation, if I hope to be in time, and tell a little bit more about the field trip that happened and that is also planned. And then, of course, that is outreach, and there's a lot to do in outreach, because right now we have more to tell about this project, about the results, and about the way forward this year and the coming years also. The project already showed that its uniqueness. And Marine Littoral Association, that is something that can be established in Azerbaijan even after the project is finalized nominally, which is the final year is this year, but we just start the process, and this process may roll on. And that is, of course, local initiative. We cannot establish this association or empower NGO or Water Expert Union or Caspis.net, you can name yourself, with these tasks to run the project years after the project is finalized. Then, as I told, with field expeditions, that is the most exciting and the most important part of this work package, and I would say actually of the whole project. That is as I see it. And last summer, despite COVID, our Azerbaijan partners, they managed to arrange a full-scale expedition with education and training, and there were on-site investigations and ground truthing with collection of plastic materials and cleanup operation, because for scientists, from time to time, it is important to leave the plastic or leave the debris, leave litter on site. For people living in the area, of course, if you see it, you better remove it. So what balance we find here, that before you remove, you register. And in this case, we do the mapping combined with good cleanup action. So this summer, of course, there will be another expedition. There will be more talks about that with better and more, how to say, direct Norwegian participation and the use of new technologies. Bert will tell more about that, about micro near camera and smartphone near scanner. So we'll come to that. So that is very nice that this year it will not only be copied expedition from the last year, but there is a certain improvement in terms of scientific subjects. And then in outreach, we also do almost the same what we did in Malinor and Artomal. What I mentioned, there is a project website, presentations at conferences, seminars, workshops, and meetings. We publish news and reports in media, and so on. And WebGIS is to be launched. That is an interesting thing, and we have everything for that. And in this project, it can be a combination of field expeditions and modeling and exciting pictures with drones and satellites and everything. So that is nice toy to play with in a way. And what is new for this project, actually, that is initiative from Payham, is to make, as he tells, movie or video presentations about the project. And we are in the process of making it. And we plan to make 2 presentations and 2 movies, one short advertising for 5-10 minutes, and one more oriented to the lecture. about half an hour or probably academic hour. So that is a new thing to come, and that is exciting that we also, through the project, we come up with new ideas and develop the outreach concepts and implement that. More introduction of social media would be also interesting, especially by those volunteers and students who take part in the field trips. Because we are sure that you share your experiences, and for us it would be interesting and important to know how you communicate about what you learn through this project and what you do through this project. And about presentation at conferences, this project, we submitted 2 abstracts to, as I understand, the biggest international marine debris conference. There will be 7th one arranged and held in South Korea in September. So, and we submitted 2 proposals, and both on CRIPTIC, and both were accepted. One for poster and one for oral presentation. And I should mention that the one for oral presentation that should be given by Begam, it is scheduled for 21st of September at starting at 9:45 at International Cooperation Section. 9:45, I believe that is Korean time. So Begam can be well prepared for that. And to mention that is only one of only 3 oral talks at the whole session. And the first one is from the Caspian region, from Norwegian-Azerbaijan project. The second one is international, by International Atomic Energy Agency. Interesting that they're speaking about marine debris and plastic. And the third one is from Mexico. So that is interesting, and it's a very good result already of being accepted in such a team. And, yeah, rather just to mention your calendars, but we will inform you later on, and to think a little bit more about the future. So of course, when we draft the project and project ideas for this project, we have target groups for public awareness and community engagement. And of course, when we think whom to engage and whom to involve, mostly think about the region, and most of all stakeholders in Azerbaijan and Caspian Sea region. And these are local population and authorities that take decisions, but those decisions should be made and prepared by somebody. We of course think about industries, because they're the ones in fact who pollute and who can prevent. They think about research and education institutes. They're mostly our partners, and they're those who work as a driving force for the whole project. NGOs, that is enormous resource, that both have hands and motivation and brain, and they bring the idea to the future. And then of course we think about foundations, not about Norwegian one that finance this project, but about also other foundations that can come into the project and into its idea after 2022, or even during the project implementation. So that is what we started the project idea with. But actually, when we went through the process, then we felt like why the target groups are only or mostly in the Caspian Sea region. Actually, we also have the same target groups in Norway and outside Caspian Sea region. So what is important for the region is that those who cooperate under the project umbrella, they also spread information about the project in their countries among themselves. Because more people in Norway know about the project and the Caspian region and its problems, but we are on the way to find solutions to them. And of course, given the talks and international conferences, that is both to show our own results, but also to involve other participants into nice region that has certain problems that can be solved together. So coming back to the first slide, or almost the first slide, actually there is no last slide here. And as I tried to mention in the beginning, because for CRIPTIC as a project, we have work packages, we have tasks, we have partners, we have the budget and time frame, which has been extended a little bit due to COVID, but anyway, it will end. And we need to reach and show certain results by the end of the project. But for CRIPTIC as a platform and as a concept and as a process, there is no limits, no geographical limits, no time limits. And when we manage that, then we manage the main idea of what we call engagement and awareness of people. And then it will be, as I told, both ways in multi directions, science for people and people for science in this way. Thank you.
Thank you very much, Alexei. Surprisingly, both you and Niels actually finished exactly on the time that you should finish. Of course, you delayed like as 1 minute or two, but I didn't cut because, yeah.
It was because of you. You let me start later. No, sorry.
Okay, okay. You
Yeah,
can always project upon me. Yes, questions. You put forward so many interesting points, and I assume there should be several questions. And
I have myself questions to Elnur, and yeah, if there are questions to me, of course, welcome to ask. But when it comes
but it's
to
not your
field,
turn, Alexei. Just
yeah.
wait and sit and answer. It's not your turn to question. But I see Emil is trying to say something.
Yeah.
Emil from Kazakhstan. Okay,
Yeah.
it's kind of lost for Azerbaijan. Now you are representing Kazakhstan. Emil.
Thank you so much. Thank you, Professor Pegam. Thank you so much, Professor Alexei. That was a really great presentation. Excellent. You know, really a lot of like also wide range of activities. Really impressive. So I'm just wondering, while you were also explaining, like very good, you were actually showing a nice presentation. I was trying to calculate kind of the business value and business investment and also business value and also output. What is the actually reasonable cost out of that, right? So basically, like I looked at the pricing also of the e-cognition, and it's ranging normally from $8,000 to $20,000. Yeah, and if you calculate 20,000, let's say we are taking for the not academic, but we take it for the business cost, right? And multiply by the number of our participants, right? And the cost when you are multiplying, you will ultimately get like $100,000, right? And when you are like trying to look at the equally at that stuff, you can hire for this course for the cleaning of this beach, for the range that Elnur captured, using the drone. You would spend actually less money if you hire 1,000 people to cleaning that in like two hours. Right? If you are looking at how you are supposed to, I'm very much concerned, honestly, about the sustainability of this project, because the investment cost into this project is too high. And plus, it's academic is still gonna be costing money. It's not gonna be free of charge, and each license is gonna be of high value. So how would you actually consider that in advance so that this project is kept to be sustainable for the future and all the time used by the people? I have a couple of ideas, but I'll address maybe them by the end of this so that not to spend our time and give opportunities for others questions. All right, thank you so much, Professor Alexei. That was really great. Thanks for that.
Am I to answer? Or... Yeah,
Yes,
actually, I
Alexei.
agree with both your ideas that you would like to come up in the end. So that is our way of sustainability. And I really mean it, because what is good with citizen science, and I especially mentioned NGOs and their involvement, that is enormous resource of making idea alive. I could give you some example. Yeah, okay. One short example from the Russian far north. Once I did a project actually for Sweden in a small village of Soina in the White Sea coast. So when we came there with the idea to establish a national park, 99% of population was against that. After half a year of our work with school children, 90% of population was for establishing the national park in the area. And when the project was finished, they continued without any investments, financial investments from our side. So even their teacher of biology became a teacher of the year in Arkhangelsk region. So that is the way for sustainability. Anyway, so of course, what is good with such multi-sectoral and multi-projects that each element can survive independently. And if we put too much economy thinking and this pragmatic economy thinking on the table in general, we would never send a person to the moon.
Thank you, Alexei.
So
There
that
are
is
other
yeah.
questions waiting, and I think this is a very nice topic for discussion part. And thank you, Emil, you raised that. But Alexei already mentioned, and we don't really. We shouldn't forget the starting point of this project, mapping for cleaning. Without mapping, you can, of course, you can send thousands of people to clean, but you need to repeat it. You need to identify the problem first, and then at least this is the method we do in Scandinavia. We identify problem. Prevention is better than cure. Ounce of prevention is better than tons of cure. So this is the approach, but we can talk about it on the discussion. Professor Rustam, please.
Thank you very much. My congratulations. Both presentations were very, very good. But I am scientist, that's why my question related to science aspects of the presentation, which was done by Niels. Can I ask him? Is he here?
Yeah, but Professor Rustam, Niels will have another session, and you will have opportunity to talk and ask question in the second session of Niels. The second session will be exactly what he has done in CRIPTIC. Then you will have opportunity to talk about that and discuss about that. Again, we will have discussion session to talk about these things. So
Okay.
I recommend you preserve your question for that session.
Okay,
I saw Yannicka. Yannicka, did you have a question? Or yeah, please.
It was more a short comment to
Please.
the relationship between volunteers and professionals, and I agree with Alexei that volunteers and NGOs play a really important role in collecting data and increasing awareness. But what we have been struggling with in Norway is the understanding that the data also needs quality control by scientists. So you need to figure out how you can get funding for this cooperation, so that we make sure that the data quality is good and the data is actually used, because that's citizen science data is underused both in Norway and globally today, because it's hard to get funding for using this kind of data.
That's also a very important point, because processing the data, raw data, comes from citizen scientists, and without quality control, it is time consuming and needs budget. And this is some other difficulties that we have in plastic concern studies. If there is no any question, we can close Alexei's session. I don't see any hands. So as usual, I try to brief what Alexei mentioned from my perspective. Alexei actually start with a very actually sophisticated, but at the same time simple question. Scientist and citizen, which one teach which one? And that's something that we really should think about that. You know, time is changing, and now my 10 years old daughter and 6 years old son, they arrange beach cleaning from school, and they go to Sandvika, Blackstad, and different beaches around where I'm living. And they clean the beach and gather information. They have log sheet. They just check mark what sort of plastic they clean. So it is kind of, I feel it is kind of race between citizen and science. So scientists actually do their job, and citizens they do their job. And which one teach which one is a very sophisticated, at the same time simple question that Alexei already mentioned, and we need to think a little bit more about it. Another interesting point that Alexei mentioned, Alexei had a journey toward the Arctic, and I would say, Alexei, it is not that far and that off, because Caspian Sea is the southernmost Arctic type water body. So there is a huge similarities between Caspian Sea and Arctic water. And in that sense, actually, you addressed us the right location. You also mentioned that the number of the Azerbaijani partners are growing. That's very important point that you mentioned, and most probably in the discussion part, Elnur will touch upon that. And that's another, actually, I think another thing that CRIPTIC should be proud of, that we start with the small number of Azerbaijani partners, and even in Norway and Azerbaijan, on both sides, there were people that they were not believing that we can conduct this project in such a geopolitically difficult location of the world. But not only we conduct the project, now we are increasing, and we are gathering more and more partners from Azerbaijani side as well. You also mentioned a question, and you were very actually enthusiastic to ask this question. What is the best way to reach out to different audience? And you were about to ask him again in the question part, which is another important question. You also mentioned the paper and video and some other details which are quite important in the dissemination of the project. And your last actually comment was very nice, and it is kind of mind tickling, because you mentioned the project is limited, but the CRIPTIC concept is not limited. And that's what exactly we need to see. Of course, starting a job is time consuming, budget consuming, but when you start it and you pass it to the next generation, schools and volunteers and universities, then you will see it will go with low budget, and it turns to a habit. So the Marine Litter Association is something that we should seriously think about it. Me, you, Alexei, and the whole team of project for later on. By this, I would like to finish your session, Alexei. We are not exactly, just 1 minute delay. On the break time, we will have 15 minutes technical break. In Norwegian time, we will get back at 10. Now it is 9:46, so it will be 14 minutes time break. I ask all participants not to leave the room, just leave it like that and close your video and your mic and get back in 14 minutes.
By the way, we are 71 now participants.
Thank
That
you.
is good.